Let's look at solving equations. Specifically, we are going to look at solving single variable equations. There's a couple steps that we are going to follow each and every time we solve a single variable equation. The first thing we are going to always try to do is distribute, if we can do so. The second thing we are going to do to each of the expressions is combine like terms. The third thing that we will do is move our constants to one side of the equation. The fourth step, we will move our variables to the other side of the equation. And then the fifth step, we will remove any coefficient from the variable. One example might be 3x plus 2 times the quantity x minus 1 equals 6. You'll notice that because we have a set of parentheses, we need to distribute first. So in this case, we will distribute our 2, and then that would give us 3x plus 2x minus 2 equals 6. Remember, when you're distributing, you are multiplying. The second step is to combine like terms. We have 3x and 2x on the same side of the equation. When we add those together, that will give us 5x minus 2 equals 6. Step 3 says to move your constants to the one side. I'm going to add 2 to both sides, and that will give us 5x equals 8. Step 4 says to move your variables to the other side. All my variables are already on the left, so I don't have to worry about step 4. And the final thing is to remove the coefficient. To get rid of the coefficient, we are going to use division, and that will leave us with x equals 8/5, or as a mixed number, 1 3/5. Let's look at another example. Let's look at the equation 3 times the quantity x plus 2 equals 6 minus 3 times the quantity 2x plus 1. In this example, we have two sets of parentheses, so we're going to have to distribute on both sides of our equation. First, on the left, when we distribute to 3, we will get 3x plus 6. On the right side, we will distribute a negative 3, so that will give us 6 minus 6x minus 3. We have no like terms on the left side, but on the right side we have a 6 and a minus 3. So when we combine those terms, we will be left with a negative 6x, and then 6 minus 3 is 3. And then we add 6x to both sides, which will give us 9x plus 6 equals 3. When we subtract 6 to move our constants, we will get 9x equals negative 3. Finally, we will remove our coefficient by dividing both sides by 9. And when we reduce, we see that x equals negative 1/3. So to recap, distribute first, combine like terms, move your constants to one side, move your variables to the other, and finally remove the coefficient. For a third example, we have 4x minus the quantity 2x plus 1 is equal to 3 plus 2 times the quantity x minus 4. Our first step is to distribute. So on the left-hand side of the equation, we have a minus sign in front of the parentheses. We can put a 1 in there and distribute that negative 1. That would give us 4x minus 2x minus 1. On the right side, we have a positive 2 that we need to distribute, so the 3 will come down. And distributing the 2, we get 2x minus 8. The second step is to combine like terms. On the left-hand side, we have a 4x and a negative 2x. That would give us 2x minus 1. On the right-hand side, we have a 3 and a negative 8. When we combine those constants, we would be left with 2x minus 5. When we subtract 2x from both sides, you will notice that they cancel out on both sides, and we get negative 1 is equal to negative 5. This is a special case that happens sometimes when we are solving equations. Because our variables have canceled out and we are left with this statement, we will evaluate this as either true or false. This statement is false, and this is an indication that there is no solution. No matter what we substitute in for x, we would never have the same thing on both sides. Okay, let's look at a fourth example. Two x minus 1/2 times the quantity 2x plus 4 is equal to 10. The first step is to distribute. In this case, we have a fraction that we are going to be distributing, and it's a negative 1/2. So when we distribute the negative 1/2, we have negative 1/2 times 2x, which would give us a negative x. And negative 1/2 times positive 4 would give us negative 2, and all that is equal to 10. Our second step is to combine like terms. We have a 2x and a minus x on the left-hand side. When we do 2x minus x, we'll be left with x minus 2 is equal to 10. Moving our constant by adding 2, we find out x is equal to 12. And we're finished. This one did not involve moving variables to both sides because we didn't have them on both sides. In addition, there was no coefficient of x, so we are simply finished after we move our constant over.